All right, let's show that the natural log of x grows slower than the given function, which is the fifth root of x. And again, we want to show that natural log of x grows slower, which means we want to show the fifth root of x grows faster. We're going to look at a limit as x rolls towards infinity. And again, I want the faster equation on the bottom just for me personally, so that's going to be natural log of x over x to the 1/5 power. Okay. When I put infinity in, I get infinity over infinity. That's an indeterminate form. So I'm going to let the top equation be f of x. So f of x is equal to the natural log of x. The derivative of that, the derivative of f of x is equal to 1 over x. G of x then would be x to the 1/5. And the derivative of that guy is 1/5 x to the negative 4/5. The other way to think about that one is 1 over 5x to the 4/5 power. Okay, so top divided by bottom, which is 1 over x over 1 over 5x to the 4/5. And when you multiply by that reciprocal, that becomes 1 over x times 5x to the 4/5 over 1. Okay, 4/5 and x reduce, okay, because of your exponent rule. So 4/5 minus 1 is 1/5. So this becomes 5 over x to the 1/5 power. Now, as x goes to infinity, this whole guy goes to 0. And that shows that as x gets large, we go to 0, which means that the natural log grows slower than x to the 1/5. Okay, question 15, we want to show that these two functions grow at the same rate. We've got the fourth root of 8x to the 8th minus 2x cubed plus 1 and x squared. So we're going to use a little kind of a trickeration item on this guy. And we want to try and compare these. You know, I've got this fourth root and I've got this square root. So when I look at that limit, it's a difficult one to sort out. So let's go ahead and look at this guy. So this is what I've got, and we want that x to go to infinity. But from here, when we go to infinity, it's just really challenging because of that fourth root and the squared. So one thing that we can do is rewrite that bottom as a fourth root. And when I rewrite the bottom as a fourth root, just think of what you're doing. You're taking 4 of somethings to get them under that root. So I would have 8x to the 8th minus 2x cubed plus 1 on top. That's this fourth root. On the bottom then, it would be the fourth root of 8 of x to the 8th. Okay, just think about that for a minute. The fourth root of x to the 8th is going to be x squared. The cool thing with this is I now have a big problem that's the fourth root of 8x to the 8th minus 2x cubed plus 1 over x to the 8th. And here's a situation where I can now look at that leading coefficient, this guy right here, this guy right here, and I can reduce those all the way down because that's the behavior that will happen for really, really, really large values of x. And if you don't like thinking about it that way, you can also split this rational expression up into its little sums and differences. So 8x to the 8th over x to the 8th minus 2x cubed over x to the 8th plus 1 over x to the 8th. And as x goes to infinity, these guys will go to 0. Okay, which just leaves us, again, with this first set of leading coefficients and leading terms. All right, back to my problem then. I'm looking at the limit as x goes to infinity of the fourth root of 8x to the 8th over x to the 8th. And as long as this reduces down to a specific number of some sort, then I have two functions that grow at the same rate. Well, the x to the 8th cancel each other out, and I'm left with the fourth root of 8. Now, I don't know what the fourth root of 8 is, but I know it's a number, and since I know that I have some number, some limit factor here, then I can say that these two functions do grow at the same rate. Okay, what we're going to do with this problem is express this indefinite integral, improper integral, as a limit of definite integrals. So the only thing that we need to really worry about and investigate is this guy. For this problem, is this guy right here. We're going to take him out and put a variable in, and then we're going to look at a limit. So the not a highlighter though. The limit as some variable. In this case, we can call it a or b or c or whatever. A, as a approaches negative infinity, of the integral from a to 0 of 18 over x minus 1 squared dx, is exactly how we would write this, from an improper integral to a definite integral with the limit. And that's really all there is to it. We would evaluate this, but we're not asked to on this problem.